Hello there, and then welcome to a brand new lesson. This is Hap Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at operations on fractions, and specifically, we look at addition of fractions, how to add like fractions, unlike fractions, and probably that of mixed fraction as well. So without much ado, let's quickly look into it. So when it comes to like fractions, we initially said that they are fractions with the same denominators, okay? So when you want to add fractions with the same denominators, the rule is you just add the numerators only, and then you keep the same denominator. You see, you keep the denominators the same. And this is the basic rule we use to add fractions. So let's take some examples and then we see what this really means. So with this example here, it says we should add 1 over 5 to 2 over 5. What is it going to be? You take note that these two fractions you have are like fractions. So that is 1 over 5, and you are adding it to 2 over 5. So since the denominators are the same, we just write the denominator. And then we add the numerators. That is 1 plus 2. And we know 1 plus 2 gives us what? A 3. So we have 3 over 5. You see, very simple, because they are like fractions. The same way, if you had 5 over 12 and you wanted to add it to, let's say, 1 over 12, we are following the same procedure. We have our 12, that is, since the denominators are the same and then they are like fractions, then we just add our numerators. So we add 5 to 1, which then gives you what? Your 6 over your 12. You see, and 6 over 12 can be simplified further to give you what? A 1 over 2. How do you get a 1 over 2? We are dividing the 6 by itself. So 6 divided by 6 giving us 1, and then 12 divided by 6 also giving us 2. So basically, this is how we add like fractions. Let's look at how we can then work on unlike fractions. When it comes to adding unlike fractions, we know unlike fractions are those with what? Different denominators. The rule is also very simple. Since we know it is easy or easier to add like fractions, then all you need to do is to express your unlike fractions as like fractions. And how do you do that? You make sure the denominators are the same by using the LCM. So if we have an example such as 1 over 2 adding to what? A 1 over 3. As you can see, the denominators are different. So we need to make sure they are the same. You see? So for this first example, I'll explain to you what the LCM means, and then I'll assume you already know how to do it from our previous lessons. If you have 2 and then 3, let's look at the multiples of 2. So we have 2, we have 4, we have 6, we have 8, and it goes on and on and on. Now, if we take 3 on the other hand, 3 has multiples 3, then 6, then 9, and then 12, and it also goes on and on. So we are looking at the smallest number that is both a multiple of 2 and then of 3. And as you can see, that is 6. This is. So instead of our 1 over 2 plus 1 over 3, we are going to say the lowest common multiple or the common denominator of 2 and then 3 is 6. You see, so this LCM becomes your common denominator or the common denominator of these two fractions. So with your LCM written, what you do is you ask yourself, how many times does this 2 you have here divide the 6? 2 divide 6 3 times. So that factor 3 now multiplies your numerator. So that you have a 3 times 1. The same way you have 3 dividing 6 2 times. So that 2 now multiplies this numerator you have over here. So you have 2 times 1. The rest is just simple operation. So you have 3 times 1 giving us our 3 plus 2 times 1, which also gives us our 2. Then we say all over 6. Evaluating further, we are going to get 3 plus 2, which is a 5, over your 6. And this is your final answer for 1 over 2 plus 1 over 3. Let's take some few more examples, and I'm sure it'll be good to go. Okay, so for this second question we have here, it says 3 over 4 plus 5 over 8. How do we go about it? So we have 3 over 4 plus your 5 over 8. And as I said, we look for a number that both 4 and then 8 can divide. You see, both denominators should be able to divide them. Now, that number is actually 8. Because if you take 8, 8 can divide itself. And then 4 can also divide 8. You see. So, we write the 8 down here. And then we start our operation. So 4 divides the 8 how many times? 4 divides 8 2 times. So the 2, which is that factor, will then come and multiply this numerator. You see. So what you are doing is you divide your common denominator by each denominators, and then you multiply by the numerators. So that we have 4 dividing 8 twice, then 2 times the 3. So you have this here. Not forgetting your operation. So plus. Then you have 8 dividing 8 once. So that 1 now multiplies our numerator. So that we have 1 times 5. You see. So simplifying, we have 3 times 2, which gives us a 6, plus the 1 times 5, which gives us a 5. You see. So simplifying further, we have our 6 plus 5, which is 11 all over 8. This here is our final answer. But you can choose to write it also in another form, that is in the mixed fraction. That is 8 divides 11 how many times? So you have 1 with a remainder of 3 all over 8 as your final answer. You see. So that is how we add unlike fractions. Make sure you write both fractions with the same denominator, that is using the LCM, after which you can continue with your operations. Now, when it comes to mixed fractions, they also have 2 ways you can add them. You see, so when it comes to adding mixed fractions, let's take some examples, and then from that I would explain to you. So we have, with your 3 whole number 1 over 5 plus 2 whole number 3 over 5. So 3 whole number 1 over 5 being added to 2 whole number 3 over 5. The first method is, since we have whole numbers, let's add the whole numbers separately, and then we also add the fractions separately. And then the second method, you have to change both fractions toward their improper forms. So let's look at both. Then you can take the one that you think suits you. So for the first one, we are going to add 3 to the 2. That is these whole numbers. This is the 3, this is the 2. After which, we then add the fractions. So we have 1 over 5 plus 3 over 5. You see. So 3 plus 2 gives us a 5. So you have 5. Then these are like fractions. We've already looked at how to add like fractions. So that gives us 4 over 5. You see. And simplifying it, we have 5 whole number. There's a 5 whole number with a fraction 4 over 5. You see. So this method, or this method, actually add the whole numbers separately, and then you think of adding the fractions as well. Now, the other method that says you should change both to their improper forms. Let's look at how that also plays out. So you need to change 3 whole number 1 over 5 to its improper form, so that you multiply your 3 by your 5, add the 1 to it. That is 3 times 5 plus 1 all over your 5, then plus your 2 times 5 plus 3 all over your 5. All of this then gives us your 16 over 5. Easy. And then plus, this also gives us a 13 over 5. Now we have two fractions that are alike. Since the denominators are the same, all we do is we then add the numerators. That is 16 plus 13. That gives us a 29 all over 5. So 29 over 5 is an improper fraction. Hence, changing it into mixed fraction, we have our 5 whole number 4 over 5. And they are all the same. You see, so the method that suits you, you go with that. This one here says add your whole numbers and then you add your fractions. If the fractions are like fractions, you do it just as we did for the like fractions. If they are improper, you also do the same. And then this other method says you should what, change all into their improper forms, after which you deal with them individually. So as usual, I'll leave you with some questions so you try on your own to test your understanding. We have 3 of them here. You have to add and simplify. These are like fractions, these are unlike fractions, and these are mixed fractions. I do hope this lesson was helpful. If there's any issue of concern, you can always let me know at the comment section. And if you so do wish, you can choose to subscribe so that anytime I release a video, you'll be notified as well. See you in our next session. Then bye for now. Stay blessed.